class. Today we're going to learn about matrices.
Ooh.
Yeah. Come on, matrices are fun and easy to learn.
No, they aren't. We're all confused by them. I bet you can't find one person who truly loves matrices.
I do.
What's that?
Someone very special to show you guys how fun and easy matrices really are. Hello everybody, I'm Madam Matrix, and I'm the only matrices superhero in the world. I love matrices, and by the end of it, you guys are all gonna love matrices. Yay! We'll start with the basics. What is the beautiful thing we call a matrix? Well, it's an ordered array that makes comparing data way easier. It's enclosed in brackets and is described by its dimensions, and each value inside of it is called an element. There are four basic types of matrices. A matrix with one row is called a row matrix. And a matrix with one column is called a column matrix. A matrix with an equal number of columns and rows is called a square matrix. And finally, a matrix with only zeros for elements is called a zero matrix. Simple, right? See, it's so easy. Equations with matrices are just as easy. When adding matrices, you must find the sum of the corresponding elements in each matrix. When subtracting, you find the difference of the corresponding elements. When you want to multiply a matrix by a single number or a scalar, you multiply each element in the matrix by that number. Multiplying two matrices, however, is a bit more difficult, but I have some easy to follow steps to help you out. Multiplying matrices can be a daunting task, but I have 5 simple steps to make it seem like a piece of cake every time. Let's get started. Before multiplying any matrices, you need to be sure that the number of the columns in the first matrix is equal to the number of rows in the second matrix. If they are equal, then you're good to go. Now I'll tell you the 5 steps to multiplying matrices. Step 1. Multiply the numbers in the first row in the first matrix by the numbers of the first column of the second matrix and add the products. Put the result in the first row, first column of the answer matrix. Step 2. Multiply the numbers in the first row of the first matrix by the numbers in the second column of the second matrix. Add the products, and put the result in the first row, second column of the answer matrix. Step 3. Multiply the numbers in the second row of the first matrix by the numbers in the first column of the second matrix. Add the products, and put the result in the second row, first column of the answer matrix. Step 4. Multiply the numbers in the second row of the first matrix by the numbers in the second column of the second matrix. Add the products and put the result in the second row, second column of the answer matrix. Step 5. Simplify the answer matrix, and there you have it. If that seems like a lot of information being thrown at you, there's an even simpler way to look at it. You write out the equation, multiply the rows by the column, and then simplify. Now I'm going to tell you how to use matrices when working with geometry. First, put the coordinates of a figure in a matrix that looks like this. For reflection, you need to multiply the matrix that corresponds with the axis you want to reflect it over. Here's a chart with the matrices for each type of reflection. Doing a rotation is very similar. You multiply the matrix with the coordinates by the matrix that corresponds with the degree of rotation you wish to turn it by. And here's a chart for that. Matrices are a great way to make geometry a little bit easier. Every square matrix has a number associated with it called the determinant. When finding a determinant, the matrix is enclosed in two parallel lines. It looks like this. Finding the determinant of a 2x2 matrix is super easy. You find the difference of the products of the two diagonals. Here's an example. The answer to this determinant is 2. Finding the determinant of a 3x3 matrix is a little bit trickier, however. I've put it into two different methods which make it seem so much easier. The first method is called expansion by minors, and it's super easy to understand. The minor of an element is the determinant formed when the row and column containing that element are deleted. And that would look like this. The final equation for expansion by minors looks like this. Please note that they alternate between positive and negative. If you think that is too complicated, then you can try using diagonals to find the determinant of a 3x3 matrix. There is 3 simple steps to that. Step 1 is where you rewrite the first 2 columns to the right of the determinant. Step 2, you find the products of the elements of the diagonals. Here's an example. Step 3 is you add the bottom products and subtract the 2 products, thus making the determinant for this matrix 13. See how simple determinants can be? And the finally totally awesome thing in teaching you guys about matrices is Cramer's rule. It's a nifty little trick to use when solving systems of equations with more than one variable. Here's what the equation looks like for solving a linear equation with 2 variables. To find x, you must find the determinant of the matrix with the elements e, b, f, and g, and divide it by the determinant of the matrix with elements a, b, c, and d. To find y, you must find the determinant of the matrix with the elements a, e, c, and f. Then you divide it by the determinant of the matrix with the elements a, b, c, and d. But that matrix cannot equal 0. When solving an equation with 3 variables, it is a similar process, but the matrices you divide by are slightly different. When your equation looks like this, these are the matrices for solving each variable. When solving for x, the numerator will be the determinant of the matrix with elements j, b, c, k, e, f, l, h, and I. When solving for y, the numerator will be the determinant of the matrix with elements a, j, c, d, k, f, g, l, and I. When solving for z, the numerator will be the determinant of the matrix with elements a, b, j, d, e, k, g, h, and l. And the denominator matrix for all 3 variables will be a, b, c, d, e, f, g, h, and I. And the determinant for that matrix cannot equal 0. This may seem like a lot to remember, but here are some hints to help you out. When solving for a variable, the constant that goes with that variable never shows up in the numerator, and the columns of these matrices are always the different constants from one variable. The patterns are not hard to find, and with some practice, it gets super easy. Well, students, that's all I have to teach you about matrices today. I'm sure if you have any questions, your lovely teacher can answer them for you.
No, Madam Matrix, don't go.
But I have to. There's all kinds of other children that I need to help learn about matrices too.
Thank you so much. You made learning matrices super fun and easy.
They are super easy, but now I must go and help children love them as much as we all do now.
Every morning, I wake up just the same. Another victim of ordinary fame. I don't see myself as invincible. It's not.